wanted to ask you that most of your works, they are also connected to some kind of low resource languages. What motivates you to work with low resource languages?
I have plenty of things to say about that. So the first thing is that, my PhD was on multilingual NLP, so it's like a natural extension was to continue working on that area, but I'm not working only on low resource languages, but that work is still dear to my heart. Like if we go from another angle, which is more like a machine learning angle, low resource languages and multilinguality also give you a very nice test framework for whatever you build architecturally, because there you cannot just use that scaling up hammer, because inherently we face limitations in terms of first the data itself when we deal with low resource languages, and then you kind of have to be more creative in designing solutions for them, and we just cannot solve them by following the bitter lesson.
Welcome to the AI House podcast, the podcast where we speak about cutting edge technology and AI. I'm its host, Roman Kisling, and today we have an international guest, Ivan Vulic, a principal research associate in Language Technology Lab in Cambridge and also visiting researcher in Google DeepMind in Zurich. We are talking about low resource languages and NLP in general. So, Ivan, hello.
Hello.
Before we jump in, a quick reminder. It's always a good idea to support our defenders. Please consider to donate to the fund that we support. Link will be in the description of this video. Thanks again for joining. So let's get started. And can you please give us a little bit background about yourself, about your work, research?
Okay, we said no difficult questions, but this one is very broad. Yeah, just before we start, I just wanted to say that what I will be saying in this podcast just reflects my own personal views and not the views of any institutions I'm currently affiliated with. So I'll be talking in my personal capacity. Right. So going back to the question, now that I've been in this field for many years, even before we called it really AI. So I did my PhD in NLP completely accidentally at KU Leuven in Belgium. And after that, I went for a research visit to Cambridge, and then there was like a postdoctoral position in Cambridge. I kind of liked the project. It was like a big ERC project. And then I stayed in Cambridge ever since. So it's been almost 10 years there. And in the meantime, I also spent 7 years working for a startup company called PolyAI in London. So I worked there as a part-time senior scientist. It was like a lot of fun because I saw this connection between fundamental academic research and applications of research in the actual systems that that company worked on and still works on conversational AI systems. So it was really fun to actually see interactions with all sorts of people over the phone. And now I am, as you said, a principal research associate, which is like a very Cambridge specific title. I can explain what it means if you want to know more. And right now I am visiting Google DeepMind in Zurich. So I am actually sitting in Zurich at the moment and speaking about my life journey that you just heard.
Yeah, it seems really natural path. Like you started with NLP and continued it all the way.
Well, not really, not really. I'm trying to kind of expand my portfolio and connect more dots. So I really started with like call it niche NLP in a sense that I worked in distributional semantics, only with language, etc. But now my research portfolio actually moves more towards machine learning models and architectures, and also covers different modalities. So now I have some experience working with like audio, speech. Yeah, that means speech, multimodal, so like vision. Some of my latest like most impactful, call it, research actually deals with some of the uh, visual parts of learning, and I really want to like expand the portfolio, which also means expanding the horizon of research and connecting all the dots with, well, things are actually very related, very similar, but you get to see that only when you have like a broader overview of the field, and that comes with, I would say, experience as well.
Yeah, definitely. Uh, lately I think that I'm kind of feeling that if previously, when the like in the lives that were before Transformers, you could do only NLP, and that was like the primary part of someone's career. So now, when you've got all this vision language models and everything else, you need to expand to something else. So it's like kind of necessity.
I mean, yeah, you have to adapt, but the things that actually make it easier for you is that all the architectures of all the models that deal with all the modalities actually kind of converge to very similar ideas. So this actually enables swapping between different modalities and even like linking one modality to the other. It means that, I mean, we had transformers for text, but then people came with VITs, visual transformers, and now people are actually doing autoregressive architectures for speech processing. And this kind of just gives you a lot of, I mean, in machine learning terms, a lot of architectural bias that actually helps you to build and connect these models. So if you understand how transformers work, if you understand all the input-output processing parts, then a lot of it is actually about data pre-processing, processing, post-processing, where you're trying to convert. In a sense, we have a hammer, and then we are actually converting a lot of the signals and stimuli into the nails, and then we just use the hammer, and it doesn't matter if like the nails come from vision, speech, or text. That's how I see things at the moment.
Yeah, I didn't think that it will come up so early in our discussion, but you mentioned that for now all the main models that they are autoregressive, and I wanted to ask your opinion about it because there's like very popular.
I mean that it's not true. It's not true.
Okay.
Yeah, I mean, many of the models that actually work are especially like on vision and speech. We do have diffusion models, which have like a different paradigm. So it's like
Yeah.
a set of non-autoregressive models. So if you've followed some of the latest developments, so there was like a Gemini text diffusion model that was revealed during Google I/O, and this actually gives a new horizon related to like really quick outputs and like very efficient outputs. So I would say that, yeah, right now we do have a lot of non-autoregressive models from the diffusion angle. So there's like a bunch of people working on diffusion models, and they have their advantages, disadvantages, and also there are like models like transfusion, which are trying to combine a good, strong abilities of both types of models. So this is all like very new in the research landscape.
And from your point of view, where we are moving with this? So basically, what I mean that usually people citing Jan LeCun about it, that he's saying that autoregressive models will not give us the AGI or any kind of new advancements. So what is your point in this? So
Right. So I think that there is way beyond autoregressive models. I mean, autoregressive models came from this paradigm that is very related to language text processing and like next word prediction. But when it comes to unlocking AGI, I would say that it just depends how you define AGI. You could say that with the latest developments of models, like we've even unlocked some like not beyond AGI, or they call it now super intelligence, like ASI abilities, things that I cannot do myself very well, and I just prompt the model and it gives me a perfect solution. Like, does it mean that the model is more intelligent than I am? So I think the the question is difficult because the answer is like multifaceted as well. So it depends on the definition of intelligence, definition of general intelligence, whether we can see general intelligence as just like a sum of all the tiny bits of very specialized intelligence things, and whether we as humans also work that way. I don't want to cite or quote anything from neuroscience because I'm a total noob in neuroscience. So, I don't know how the brain works, unlike many other computer scientists. But yeah, so this is why it's like a very multifaceted problem.
Yeah, so getting back from neuroscience, so I wanted to ask you that most of your works, they are also connected to some kind of low resource languages. And yeah, I wanted to ask what motivates you to work with low resource languages, because basically you are based in Cambridge in UK, where the main language is English.
I have plenty of things to say about that. So the first thing is that, I mean, my PhD was on multilingual NLP, so it's like a natural extension was to continue working on that area, but I'm not working only on low resource languages, but that work is still dear to my heart. And basically I've seen this evolution of NLP where it was just called multilingual NLP, and basically no one has been doing any work on beyond English. So if you actually worked on Italian or Dutch, you would be considered as like working on almost like low resource languages because but then as we actually contributed more and more to the area, like this loose definition of low resource languages expanded, which means that we figured out, okay, but there are many more languages in the world, and sort of I can see the slider of how we improve things for high resource, mid resource languages, and then we're moving towards more and more or languages, which also means lower and lower resource languages. And basically one of the motivations for me to work on that is because I do like languages to begin with. Although I'm not a linguist, I kind of like listening to other different languages, understanding similarities, differences, learning new languages. Although I'm a bit conservative in that respect, so I was just learning like Indo-European, Western European languages, which are like, so I didn't go to like other languages in my own experience, but and still, like if we go from another angle, which is more like a machine learning angle, low resource languages and multilinguality also give you a very nice test framework for whatever you build architecturally, because there you cannot just use that scaling up hammer where you just, yeah, if something doesn't work, just create more data, gather more data, throw the data at the problem, throw some money and compute at the problem, and voila, we're done. Because inherently we face limitations in terms of first the data itself when we deal with low resource languages, and then you kind of have to be more creative in designing solutions for them, and we just cannot solve them by following the bitter lesson. And I mean, that's like a very machine learning motivation. If you want to like another motivation, which is often something that I start my research talks with, which is also like democratization of technology. So why would we I don't know, from the perspective of an academic, I'm very interested in making things work for, I don't know, Quechuan, which is like one of my favorite test languages. So yeah, so we would like to build solutions not only based on the number of speakers slash users of the language, but really trying to democratize, or we call it now, make technology more equitable for other minority speakers, people who actually speak other languages. So there are multiple motivations. So
Yeah, quite interesting. And also, I think that the last couple of years, there's a lot of development in this area. So, for example, this different conferences that are now going annually, for example, like Slavic NLP, UNLP that we are doing, and I know some other as well. They're like democratizing this thing. And what the biggest challenge do you see with working with such small amount of available data?
I mean that's the main challenge, that you don't have the data, because all these models actually work from just finding the patterns in the data. But if you don't have enough data, then you cannot spot enough patterns, and you will actually not see many of the patterns which are actually existing in the language. So you need to be more creative, and so the challenge is then to basically use anything you can to kind of bridge that gap towards not having the data. This is why we developed cross-lingual transfer methods, where you're trying to maybe see some patterns in a language which is very similar, so that you can just transfer that pattern into your target language. This is one solution. Another solution is they're like linguists building the like repositories and databases of linguistic data. So if we have lexicons, if we have mappings from some semantic and syntactic items in one language to another, basically use that. If we have spoken data, so there's like now we talked about convergence of text and speech models, but maybe if people actually speak the language, so you have a case here in Switzerland of Swiss German. So how can we process Swiss German if we have a lot of written High German data, and Swiss German is not written as a language, and or it is like written as you want. So it's like Swiss German is like a very interesting language to work on. So in order to solve the problem of lack of text data, you can like go around and record people speaking, and then use that data via creating links between text and speech. So I mean, we can always, not always, but based on how granular you want to do work and like how granular your models will be, you can always create this like data scarcity problem. So imagine that even if you work with Ukrainian, which could be seen as like a mid-resource language in NLP terms, maybe. What about if we want to build something for elderly people? They speak like maybe in a different way, maybe more slowly. They use a different vocabulary. They don't adapt so well to like modern vocabulary from the internet, etc., etc. So depending on where your data comes from, your model might actually suffer for that demographic group, and et cetera, et cetera. So you have this like one layer of having your languages, then we can talk about dialects and social acts and regiolects and them, those demographic layers of language, et cetera, et cetera. And whatever we build for low resource languages might actually have a direct application also beyond just low resource languages, which is also like a nice concept. Because as you mentioned, from a high level perspective, we are basically solving an issue of not having the data.
Yeah, it's interesting that you mentioned dialects. I have the paper accepted on this UNLP about adapting to Ukrainian dialect, the model.
Nice,
So,
yeah, congratulations.
thank you. But so here comes the question: what about synthetic data? Because actually, when I was working on it, it's like was a dialect from the mountains. It's quite far away and takes some time to go there and to record people, and not all of them that are living there speaking with a dialect. Most of them speaking like regular Ukrainian. And I heavily relied on the written sources that was available, and then I synthesized some kind of additional data that helped me to tune the model. So what do you think about such approach? Because from one side, it's like working, you are creating more data. From the other side, it's obviously not as good as the original data. So it's much better to go and to record people than, than to synthesize data.
I mean, I would say that the answer also depends on what you want to do with the model that you're building. So, for example, uh, yeah, if you have like a very large capable language model, if you give it some prompts, I mean, you need to create synthetic data from somewhere. So basically, you need like the best possible model to create the data for you, and then you might be able to fine tune smaller models, and then smaller models might actually do very nicely all the dialectal processing. But yeah, I would say this is like a good use of synthetic data, and it's sort of another way to answer the question is the models might actually like how to say that, transform your prompts into the actual data. So if you explain very nicely to the model what you want to create, they might actually create patterns of the data that you can control. And then you can even do like dynamic synthetic data processing, where you might teach the model which examples are good and which examples are actually not good. So with the human in the loop, you might actually create like really nice procedure to get a really good data for you. But then you still need like a human expert who understands the dialect, who maybe even speaks the dialect, in order to kind of say what is good and what is wrong in terms of keeping those data instances. So I would say, yeah, I mean, the best possible scenario, just get the natural generic data. If synthetic data may be directly useful even without the human in the loop, but human in the loop might be like a very nice middle solution, which is more like the expert in the loop. And then I can see that data as very useful, because again, like working with low resource languages and dialects is basically take whatever you have, because you have to cope with the problem of not having the data. So and I think we'll see more and more work on using synthetic data for low resource settings, but it would be interesting to measure the gaps actually. So that's like a nice research idea for an analysis paper. If you, yeah, you can work on that if you want.
Yeah, I think that basically I have a plan to record more data for when I will be there, and then to try to compare it. So it's like
Yeah.
for the next year or two. But there's like an interesting thing that you mentioned, that if you explain it to the model nicely and the big model can understand it and take this pattern and generate you the nice synthetic data. So there was another thing I was thinking. A lot of models now come with reasoning capabilities, and do you think that this reasoning capability may be used to generate this synthetic data, or even to get this kind of patterns out of it, and actually it will mitigate your need of huge data set for the model?
Yeah, I think so, because but then like when you actually, I mean, reasoning models have, let's say, like better abilities to generate what the user wants when you prompt, etc. So like if you don't care about latency and time and cost, probably you will get better data via reasoning. But again, I think the key here is human in the loop, which will also give the signal to the reasoning model, so that the model actually gets that signal that these data instances were created well and these are not, which will also mean that the model can adapt its reasoning process, and that way they can generate like more and more creative data as well. So I mean, one nice property about these models is basically that they can create a lot of combinations which would take maybe years to record from people. Let's say, like if you prompt them to say this and that and something in that way, something in this way, etc., etc. So once you actually have maybe some prompts, or call it in context examples, and you want to transform them some way, you just throw it to the model, and yeah, the reasoning model might do better than just the non-reasoning model. So I would say whatever reasoning models do better right now, it will extend to creating your synthetic data. I mean, that's my hunch. I haven't tried it honestly for multilingual NLP and low resource NLP.
As you know, YouTube promotes channels with active audience much more. So if you like what we are doing, if you like our podcast, please consider subscribing to the channel, hitting the like button, write a comment down below, and share this episode with your friends. Yeah, and here comes another question that I was thinking about. So basically, in a lot of these low resource languages, and especially dialects, you have most texts, they are on some kind of topic, right? So rather it is a novel written like 100 years ago, or it is some kind of, I don't know, magazines and so on, also quite old. There's no like conversation, no written documents on recent events. So you cannot, for example, discuss in these dialects in mostly things like I don't know, recent elections or debate on something, and you don't have this lexic, and you can so create some kind of words with this kind of patterns. But what I was thinking, will it be the correct word? Will the natural user of this dialect or low resource language use this word, or it will construct it in another way?
I would say that's also a difficult question, because dialects are also like living beings, so we don't know how humans will actually adopt the words that come into their lexica. Maybe, I mean, they will change it for sure to adapt it, but one thing that the models actually can do is some sort of predictions. So if you feed the model, for example, with, I mean, it's again, everything is about data. If you provide some data points of how certain words in the past have been adapted from like your standard language to your dialect, then the model can maybe try to guess and predict the pattern for words that it hasn't seen. It might not be fully accurate, because again, like, dialects work in mysterious ways, languages work in the same ways, but this might be a very interesting, not even a thought experiment. So that's something to try out. And another thing is also, I would say, which could be done with the latest generation of models, is kind of disentangling style from the content, which means that if the model can kind of grasp, understand the style of how people speak, irrespective of what they speak about, and then you just kind of give them the gist of the content. So you have like a newspaper headline from several days ago on, I don't know, like, Trump and tariffs, blah blah blah, and then you can just try to like transform that thing from the news headline, the way it was written in the newspaper, into a dialectal style. And then this is related to some of the work that I did in modularity, which is really like, how do we disentangle parameters which are important for generating style versus like generating content and concepts. And then if you can actually disentangle, then you can enable unseen configurations in the model, which means, okay, yeah, I have seen zero uh, data instances from about Trump speaking about tariffs in that particular language, but I've seen that in some other languages, or I've seen it in the standard language, not in dialects. But I've seen a lot of, or a decent number of dialectal examples, so you can just combine them, and then something dialectal about Trump and tariffs will come out. Yeah, I don't know. I should have picked another example, but this is the first thing that came to my mind.
Yeah. But how will you measure it? Because I was trying to do some kind of such things, and
Yeah.
I was actually not satisfied with the result. So I just like limited my synthetic data set to the topics, like which I had the original data as well. Yeah, because I had a feeling that it's too synthetic, like yeah, some kind of it.
I mean, when the models start getting creative, even if it's creative means generating synthetic data, and then of course the best evaluation would be to ask native speakers to kind of rate things on some scales. But again, then you kind of have the chicken and the egg problem, because you've started the whole thing because you don't have access to speakers, and now you need access to the speakers because you want to evaluate. And especially these things which require some sort of like creative composition and compositionality are often very difficult to measure, because like, how do we measure like the extent of composition and also the extent of naturalness for something that we personally do not speak very well, for example? And those measures are highly subjective. So I would say the only way to evaluate is really to get some humans, and then if you can't get humans, then you go into the problem of using LLM as a judge. But then LLM as a judge has the same problem, that it doesn't work really well for low resource languages. So you yeah that opens up like a new can of worms. But evaluation is, I think, one of the pain points when working with low resource languages. And basically, whenever I did some work on on languages that I don't really understand, we always had to find somebody who's a native speaker, or like at least like two people, to kind of give us some feedback on how the output looks like. Yeah, because that's like a I think that's like a continuing problem of evaluation for those types of things.
Yes, basically, without the main point here is to get someone who actually is representing this kind of dialect. So basically, I think I have read your paper about transferring Faroese. Uh, And so you got someone who knows that language, right? For that.
Oh yeah, so we had a trained linguist. So one of the quotas, Annika. So she is actually like a born Faroese who. I don't know if she's still living on Iceland, but actually that was the connection from Iceland to Faroe Islands and from Icelandic to Faroese. So she was basically our main language expert, and she went through cleaning the data, cleaning the not cleaning the output, but evaluating the output, like giving us access, finding even like all the linguistic data that we can use for Faroese. So she was instrumental to the whole process. We were just reapplying our like call it language agnostic models to Faroese, but without her, I think it wouldn't really work so well.
And this is kind of interesting because Icelandic is also a low resource language itself.
Yeah, so I mean, I don't want to really fully go there, but even like the very notion of low resource languages is very ill defined because people use it in many different ways. And so there's like a whole branch of research which actually tries to create more quantitative, objective definitions of, or like of research of language hierarchy in terms of resourceness. And I can partly reveal that in Cambridge we are actually working on something which we call like the language readiness index for NLP, which actually combines a lot of factors, not only from linguistics or but also like social demographic factors to really understand that very rich landscape of even how to define whether a language is low resource, mid resource, high resource. Could be like high resource class 7, low resource class 3, because yeah, Icelandic is a low resource language, but it still has a lot of written text. It's a standard language of a sovereign country. A lot of data gets generated, and then you have languages like Kani and Keha in like Quebec. I met some people working on that language, and there are like 100 living people who actually speak that language. All of them are older than 70. So that's also a low resource language. So we kind of need to really define properly what things are.
Yeah, because interestingly, that as I'm not mistaken, Arabic, for example, is also considering to be a low resource language, and it's because it's different in different parts of different countries, right?
Yeah, so Arabic is a very special case because there are no L1 speakers of standard Arabic because everybody speaks their own version. So I would leave proper definitions to plenty of people working on Arabic NLP, but like, yeah, as you say, Arabic is very interesting just because there's no Arabic. Everybody has their own version, and that is also why it's very interesting to study all these transfer techniques and kind of how to come from like more general concepts that are maybe shared across all the Arabic dialects versus specializing for every single dialect. So yeah, a pretty nice language for studying.
Yeah, and a lot of people are studying it. Actually, there was a funny story. We had this year a shared task on UNLP with detecting manipulation in Ukrainian, and for some reason, I don't know why, maybe because we hosted it on Kaggle, but we had eight teams from Bangladesh that were participating, and none of them knew Ukrainian, as we got from the papers which they submitted. And actually, they all made references to these different Arabic papers, and even some of them translated this Ukrainian data set to Arabic and tried the Arabic approaches.
Okay, but that's like a really like a global solution to many different problems. Yeah, I like that.
One more thing I wanted to ask you about this work with Faroese and the Icelandic. So what was the results of it? So I mean, the to what extent we can transfer the understanding from one language to another using its similarity?
I will need to read that paper again to remember the core findings, but I would say that one core finding is that if you do have like a good relative, like a higher resource language, which is maybe still like a low resource language itself. Uh, Now I'm getting completely entangled in definitions that are all the languages are low resource. But anyway, so I would say not all languages are created equal. Even from that perspective of having relatives, and that process of how languages came to existence, I don't know, they're not IID distributed. They're like so every language actually came to existence in like to this point in time in a different way. So if you do have really good relatives for the language, it could be like a larger number of maybe more distant languages which are still related, or like a very close relative. You should use those resources. Again, going all the way back to what I said, when we have low resource settings and like not enough data, then we need to give the model more knowledge, or like from machine learning terms, better initializations. So if I'm building something for Faroese, it's much better to actually initialize things from Icelandic and some other Nordic languages which are related than kind of just like have like an exploding random matrix and then hoping that the model will generate the patterns. So in a sense, again, from a machine learning perspective, it's much easier to find delta patterns than full patterns. So if the model has already learned a lot of Icelandic that it learned maybe after seeing like a lot of Danish and Swedish, so it has to learn this extra delta of patterns from Danish to Icelandic, and then when you move to Faroese, okay, the model can just learn the deltas, meaning that some of the things will be similar, and if it sees like collisions, it will favor Faroese, because the assumption is like the more recent language is what you actually want to learn eventually. But there might be a bunch of things which the model already learned, or some of the things that are missing in Faroese data might be inherited from Icelandic. Some of them will be wrong because we don't have like a colliding pattern in Faroese, just because we don't have enough data in Faroese. But many of the things might actually still be approximately correct, and that's the core idea of sort of, I see it sort of like a funneling approach, where you can, when you start training the model from scratch, like pre-training, you start from all the languages in the world, and then you kind of control it, steer it through that funnel towards your end language. So if you want to really optimize for Faroese, let's just drive the model through that specialization process so that the model gradually learns better and finer grain deltas from starting as a tabula rasa, basically.
But wouldn't it be biased towards the previous data because you feed it more with Icelandic or Danish data, and it will be more biased towards them?
I mean, it will be biased, of course, because I mean it has seen Danish and Icelandic data before. So whenever it doesn't see a pattern in Faroese, it will just lean back to Icelandic data. But it's better to be biased towards Icelandic data than to be completely unbiased and not knowing any language. So that's like sort of like an equal treatment of all the languages, is that the model doesn't know anything about anything. So but here. I mean, the bias is okay. I mean, we are kind of playing that, what I said, like the guessing game. So if we don't see the pattern, we hope that our Danish and Icelandic patterns are correct. If we've seen a pattern in Faroese, then we can remove the bias because we will trust Faroese more. That's the core idea. So we will have a Faroese model that has a bias towards Icelandic and Danish, but that bias will approximately uh, like be much better than if we had a bias towards Ukrainian and Croatian when learning Faroese. That's the core idea.
Well, it actually depends because we are training like Ukrainian LLM now, and we are really careful about bias here because there's a lot of disinformation from the Russian side, and we are trying to avoid it in our data set. And as there's a lot of data, so it's quite influential. So basically, in that kind of way, maybe the Danish influence on Faroese is not what
Okay.
Faroesian would expect.
So now I have to comment again on how we overload terms with different definitions, because when you mentioned bias, I was thinking more in terms of like
Yeah, I got it.
structures and how the language looks like, not about the actual bias in content. But but if you if you take that other bias, which is sort of like the worldview of the model, then of course, yeah, that's one of the risks, is that your Faroese model might actually reflect a lot of what Danish people think, because it actually just saw a bunch of topics only in Danish, and then a smaller number of topics in Icelandic. So that part of bias will exist in the model. So the way to remedy that is basically to do what we are calling post training these days, and there are no other ways. So basically, once you have your Faroese model, you have to go through like a series of post-training steps based on what skills you would like that model to master, acquire, or lose. So this is like this duality of pre-training and post-training. So whatever is not fixed in pre-training immediately, if you have those biases, yeah, you need to somehow have the tool that removes the bias. Anyway, okay, now I was talking about the wrong bias. I didn't really care about content and misinformation and all of those ill usages of the models. But yeah, I see the point now.
Okay, and then getting back to big models and small models. So, what do you think about if we're talking about these low resource languages, dialects adaptations, and everything else? What is more promising, to try to fine tune the big model, or try with some kind of distillation and get the small model doing the job?
Oh yeah, that one is easy. Distillation is always better. So there have been many studies now, and we also did a paper a few years ago, just before LLMs actually became prominent, where we distilled um, single language, small models for low resource languages, and also models that enable cross-lingual transfer from your language A to language B, so they cover two languages plus transferabilities. And then we distilled that from multilingual BERT, multilingual XLMR, which were like state-of-the-art models back in the day, and they were so much better than just taking the same sized models and starting training from scratch for the two languages. We have that paper that was, I don't know, 2 or 3 years ago, and right now I think there have been a lot of other studies now with LLMs where basically they just show if you just train like a much bigger model and then distill it back, it will work better. But then the key is also to have this sort of multilingual pre-training. So we're going again back to this like the funneling approach, where you need to erase that tabula rasa perspective of the model, that the model doesn't know anything about anything. So you first teach it a lot of languages where it will know some languages much better than the others. And then if you want to specialize towards certain setups, certain languages, then you kind of zoom into those languages, you give more importance to the data of that language. So, and then the model doesn't start from random in it, but it starts from like already sort of like a bias towards understanding a lot of languages, and then you distill. And that way your data is actually way more valuable if in that low resource language that you're targeting, rather than just saying, okay, I'm just going to create a small model with small data and hope that it's going to work. No, like it's sort of like a very long cut approach to go that direction, have a big multilingual model and then gradually distill it to smaller models. But I think that is the recipe to follow.
But the big model should also have this in its original, this language in its original training data set.
I mean, if they do have, it's going to work better probably, because the language is then probably at least seen to a certain part, but then its importance is of course way diluted, because the big players like English and all the other languages just eat up most of the compute for other languages. So that's like again a research question in its own right, how to balance better. It also depends what you want to do. So sometimes if you don't care about your English performance, you can actually like redistribute, resample your data so that you see more examples from other languages. But that might actually slightly reduce your English performance. If you do care about English, then maybe you still want to optimize for English and high resource languages first, and then like kind of gradually adapt the model to low resource languages. There are also solutions that do not destroy, they're not destructive to the original model. So this is why modularity is very prominent as an idea where you can just quickly adapt without actually sacrificing performance in high resource languages and things like that.
Okay. Yeah, and probably I think that actually what I was thinking about it, that a mixture of experts may also apply good here.
Yeah. So this is when I mentioned modularity. It's sort of a
Ah,
mixture of
okay.
experts. Yeah. So I just think I think more in terms of units and modules. I don't really think in terms of their actual implementation. So we can talk about maybe adapters, which are more like parameter efficient, but we can also, depending on the data sizes, we can also talk about experts and then have multilingual sparse MOE models. And I think, people are doing those types of solutions. So I think Llama 4, for example, I think they did some mixture of expert solutions, not directly for multilinguality, but mixture of experts is actually like a very organic framework to use here.
And also, like as we mentioned, that we have the main language is English, obviously, and all other languages. So, how do you see these things will evolve? I mean, that during the last couple of years, there's like a lot of English-generated text appears, right? There's like really a lot of it, and more and more data sets are coming. And even if we are creating a new data sets in other languages, there's still much more created in English. And how do you see this will evolve? I mean, in terms of internet and models, like will they become completely English and there will be separate models for other languages, or it will go in other direction and it will be better in other languages as well?
I mean, there are multiple answers to that question. So the first one is that I still think, the best performance will be observed for English and uh, like high resource languages, just because the data is more abundant and et cetera, et cetera. But at the same time, we do see progress in all the languages. So there are like two sides of the coin. We still see the gaps between high resource languages, English in particular, and all the other languages. But at the same time, our technology, our performance is also increasing for low resource languages. So it depends how you actually see things and how you want to look at things, whether you see the gap or whether you see absolute gain for different things. And maybe the gain for English is just higher, and then kind of it creates an even larger gap. But actually the long tail is getting covered, and that's a good thing. So how it's all gonna evolve, I think we will be able, for example, I don't know, with mixture of experts or some of those uh, nice architectural solutions to create models that can handle multiple languages and learn from multiple languages, and maybe their performance will not be equal, but this is why there's a difference between equal and equitable, in a sense that we would like for every language to extract the best we can for the language, given the data that we have. But we can't really say, okay, we'll have equal amounts of data for the languages. That's not going to happen. So that's and another thing which is not strictly related to your question, but this is something that I've been thinking about, is also how data is important and how controlling data is important, because because generator models now generate a lot of new language, new construct, and if you have like a like a full loop of the data coming back to pre-training data. So it means that it might actually create this like spiral where we will have more and more AI generated data that will go into model training, and it will actually adapt the model to generate more and more of such data. So eventually, if we are not careful and not controlling the data, the models will just kind of go to that data singularity where like 99.9% of the data will be generated by the model itself. So it will start losing like creativity of humans in training, because it will anyway, you see what I mean. I
Yeah.
don't think it's going to happen, but if we don't have like safety guardrails on the data, we might actually get into that pretty interesting spiral.
I would say it would be
Yeah.
some kind of sad singularity because it will be completely generated and
Yeah.
uh,
But then I mean I don't think it's going to happen, no, because people are thinking about those problems, so they're aware of it. But in a sense, it's sort of like a trivial singularity to achieve if you just remove control from the loop, in a sense.
yeah, but I don't think that even if you remove control, you need still to retrain on this
Oh yeah,
data.
yeah, yeah.
And and people that are retraining, I think they will see that something is wrong.
Yeah. So I mean, there are plenty of control mechanisms there. So somebody still has to press play. Uh, I mean, so and somebody still has to decide. Okay, this goes in, this goes out. Unless this becomes purely and fully automated, then yeah, it's not going to happen. So yeah, because somebody really needs to press play at many different stages in order to that for that to happen.
Yeah, if it would be full automated, it would be like in Matrix when everyone would become this agent, and there would be
Yeah.
a full matrix of this agent.
Yes. Yeah.
You've got the paper on ENLP that is segment any text, and this is kind of universal segmentation for the sentences. So how it works for different languages, how it becomes such universal thing.
I mean, again, through the powers of learning patterns and basically tricks to do pre-training in a self-supervised way. So you can see that as like a very specialized general model. So instead of having a model that can do all sorts of things, we just said, okay, we want to build like a universal tool for sentence segmentation that is easily adaptable to different languages, domains, etc., and so that the model can generalize to different patterns of segmentation. And then the trick was basically to create like this, like a really nice set of self-supervised objectives so that the model learns as many possible patterns of segmentation during pre-training, so that if we just feed it a small sample of sentences, when we use it for a particular purpose, it can quickly understand, okay, this is, I just need to slightly adjust my delta to that segmentation problem and I can do it. So it's also like, it's very related to what I was saying before with like multilingual pre-training and then specializing to your low resource languages. Here we just have like a very, very special task, specialized task, and we're doing the same trick. And it's even easier because our pre-training is then not like next word prediction or anything. We just pre-train specifically for the task of sentence segmentation, trying to work with different delimiters, so, et cetera, et cetera. So, I mean, that was the idea, basically. Why we actually did that in the first place was because the student of mine, Benjamin, I mean, he got really interested in sentence segmentation because both of us were really, I mean, I just dislike when people say that something is really solved, and then sentence segmentation was treated as like a solved problem, and then when you actually start digging, it doesn't work so for so many different things, and then we wanted to see, okay, even LLMs cannot really do it so well. I think the next generation is much better than the models that were there like when we started the project. But so let's first show to people the problem is not solved. It has wider implications because it's one of the pre-processing steps, and then let's build something that's like flexible, versatile, and applicable to languages, domains, and like different specializations of the models. So this is how the whole story started and ended.
That's interesting that you said that you don't like when people say that some problem is solved, but yeah, but actually some problems are.
I mean, yes, some problems are solved. Yeah, so I fully agree, but I don't know. So I can give an example of like a classical NLP task, which was all around the place when I started my PhD, which was like word sense disambiguation and word sense induction. And then even when like contextualized word embeddings came into place, that already provided certain solutions because I don't know, maybe like linguists will get angry at me, but in a sense, contextualized word embeddings already gave you like a continuous notion of senses. So instead of just having like 2 or 3 senses of word, you could actually translate your problem into the realm of real values and latent representations. So you could have very implicit way of doing word sense induction, and it's all already coded in vectors. And now, I mean, with LLMs, I think you can even like do prompting at the discrete level and ask about different senses, and those models actually work really well. Uh, Again, it might not work as well for low resource languages. So then the question is again whether this is solved or not. Even contextualized word embeddings actually worked worse for low resource languages. So in a sense, word sense induction and disambiguation is solved for English, but not for some other languages and dialects, etc. So I don't know. Do you have any example of thing of like a task which you consider solved in NLP?
Very interesting question. So I would say that actual like translation to English is already solved because like all the languages can be translated quite well to English. But then again, we are trying dialect or we are trying some kind of domain that is very narrow. Probably we will have bad results.
I mean, I wouldn't fully agree because, again, if you take the long tail of languages, maybe that won't work so well. Plus, I think some of the recent trends in MT is also to adapt models to kind of culturally aware translate things, which is a which is an interesting problem now. Like cultural adaptation of models is all over the place, so that's like a new hype in models. So I would say, but I see saturation though in machine translation, especially if you take first N languages or like the regular languages from like WMT workshops that people use, like Czech to English or like even Ukrainian Croatian to English. That works really decently well.
But then again, going back a little bit to what you said about cultural adaptation, I have a question regarding some kind of not only the text adaptation, but also multimodality adaptation. So when we are adding another layer to it, will be like images or audio or another information that we can somehow put in there. So how do you think will it benefit the language generation itself or translation? So for example, I mean that we have the English and we have some kind of low resource language in our model, and we are training not only on text but also adding some kind of video embeddings or something like that. Will it more benefit low resource language or not?
I would say it can help because, I mean, yeah, the standard story is that part of the language is actually grounded in our perception, which means that some of the things are not really uttered explicitly in language. But if you have a connection to the image, you might actually get extra information on things. So, uh, and even like when we talk about inference, if you provide an image or a video to the model and then ask it to generate like a caption or a story behind the video, that certainly can help the model, especially like when we talk about like culture and customs. And then if the model has seen that during pre-training or has a link to that like world knowledge, it can actually adapt generation based on what it sees in the image. Could be like about some festivities in different cultures, could be like about colors it sees, and you can even do like some interesting compositions of things that you see in the image versus things that you are prompted with in text, etc. So yeah, I would say again, depending on the application, but like having images is just like extra content. Then if you're smart enough about your content, you can definitely extract extra information that is valuable in training.
Okay. Now I wanted also to ask you a little bit about your Cambridge laboratory. So So can you elaborate a little bit how it works, how your process is going, how do you select topics for the research, how it is like going?
Okay, so where do I start from? Yeah, I mean, I'm not the single PI in the lab, so I'm probably like the youngest PI in the lab, but we are collaborating with each other and often like work together with our students, although the student kind of is associated with another supervisor and uh, but I would say I mean we try to keep when we select topics, we try to give a lot of freedom to the students. So we kind of just steer them towards like high level directions that we want to work on. So, I mean, when we talk about, for example, multilingual NLP and AI that we discussed in this podcast, then like it's a very broad thing when you just say multilingual NLP. So you can work that from the perspective of creating evaluation data sets, multimodal perspectives, text and speech, low resource languages, dialects, etc. So I am trying to shape like a research program for every student based on what they want to work on, and then I just kind of slightly gently steer the process. I don't want I'm not imposing topics on them, so it's sort of okay. Here are like some very broad areas that are kind of part of my portfolio, or like new areas that I would like to expand to. So that's also possible. So if a student is like brave enough to tap into uncharted territory, and I kind of see a potential in them to do that, I'm very happy to kind of give them the freedom to start like a completely new ground, and that results in some very interesting papers and findings later on if I trust the process. Um, I mean, how do we select the students? I mean, we do have a lot of applications every year, so the PhD admissions process is pretty heavy on us, but also pretty heavy on students because we have to reject a lot of people, and a lot of people are actually very strong, but there are just like a limited number of spaces. So it's like a combination of like a lot of things. So you can even see it as sort of like a mini version of how like big tech interviews look like. So we have multiple rounds, and we also have this like a cultural fit interview at the end. And I would say it's a pretty competitive process, all in all. And but I'm very happy with the process because I do like working with my students a lot, and I think I'm learning more from them than they are from me right now. But that's how it works. Yeah, the lab itself, I need to count, but it actually got expanded in the last couple of years. So there's a decent number of students now, and in terms of how they work, I mean, I do like collaborative work. I do encourage them to collaborate with each other, to learn from each other, to attend seminars, to meet with people, to build the networks. Because like doing a PhD is not only about just producing papers; it's about acquiring many other skills as well.
Yeah, and I also wanted to ask you what is the expectation, and what for the next couple of years, where will NLP emerge, and what will happen? What do you expect, or what you're excited about the most?
Okay, so that one is difficult because I'm not a Nostradamus, but I would say that I'm looking forward to. I mean, I mean, you can call it artificial super intelligence or whatever, but I'm really looking forward to these models just cracking more and more complex problems that even like humans cannot fully crack, or it requires like a lot of training and expertise to start cracking the problems. So I mean, we've seen some examples with alpha, what's the name, alpha evolve, where like yeah,
Alpha
what
Zero?
yeah, or AlphaZero and then AlphaEvolve, where basically, yeah, the model was able to crack some very difficult mathematical problems just because it had all that collective knowledge of what many different scientists, for example, have been working on, and it. Um, I would like to see more of that. So that's one evolution. I think I would like to see a tighter coupling between text and speech, for example. So like truly multimodal models that can, we already see a bit of that, like swapping modalities seamlessly. And then you mentioned that example, which was like a game changer of even like have like simultaneous translation in virtual meeting rooms, which is like amazing at many different levels. And then creating all these sorts of assistive tools that benefit people to do things way more quickly and be creative. And I still fully believe, I believe that like AGI, ASI, whatever whatever happens, with combined with humans, will actually lead to like a lot of nice things that we cannot even foresee right now. So I'm just babbling about that. But I don't know. I mean, this is what I said in one panel, but now I remember that it's like a part of the reason why I like this area is just because I have no idea what's going to happen. So then, if you ask me about predictions, that's like a wrong question. I just love the uncertainty. So some people actually, I mean, uncertainty can be good and bad. So some people do not like uncertainty because they're afraid of what might happen if we don't have full controls and the reins of. But uncertainty can also be a good thing because something great might be around the corner and we just can't see it because it's around the corner. So, yeah. Uh, if you asked me 5 years ago whether I believe that, I don't know, I'll be writing emails in German seamlessly in 30 seconds, I wouldn't say that that would be possible. But now it's just like very easy to communicate to Swiss administration that way, for example. So that kind of saves me a lot of time, and I'm very happy about it.
Yeah, that's interesting. If someone would tell me about LLMs like in 2021, I would not believe it as well.
Yeah, and it is like 2021. I mean, yeah. So BERT came out late 2018, so people started adopting it like, yeah, what, 5 6 years ago. So like just
Yeah.
5 years ago, BERT was state of the art thing, and we didn't even have multilingual BERT yet, or we just had the first version, and now we are at this level of. I think I can even prompt the model to write like Swiss German emails for me. But yeah.
Ivan, thank you again for coming. It was very nice discussion, very interesting one. And yeah, I hope that it was interesting for you as well.
Yeah, thanks for having me. Yeah, time flies when you're having fun.
Yeah, and thank you everyone for watching. This was AI House podcast, podcast of the biggest AI community in Ukraine. And yeah, hit the subscribe button and comment down below.